In this video, I will walk you through the design of a simple block platform built using a microservice architecture and deployed entirely on AWS. The platform is intentionally kept minimal. User can register and authenticate. User can create and manage block posts. Even though the business logic is simple, the architecture follows real-world production standards, focusing on scalability, resiliency, security, and automation. What are we building? A microservice-based block platform with the following core component. User service manage user and authentication. Post service manage block posts. User authentication, DWT based authentication. Database, persistent storage for user and post. Each service is independent, containerized, and deployed on AWS. Architecture mindset. Before choosing any AWS service, we define the architecture principle. Key principle: scalability. Each service can scale independently. Independencies. Services are loosely coupled. Resiliences. Failure are isolated. Automation. CI/CD and infrastructure as code. The principle guides every design decision. Service separation. We clearly separate responsibility. User service, user management, authentication, and post service, post curation, listing, and deletion. Each service has its own code base, has its own deployment pipeline, can evolve independently. Communication between services. Microservices must communicate, but how they communicate matter. Synchronous communication. Internal REST API implemented via Amazon API Gateway. Asynchronous communication. Event-driven architecture. Implement using Amazon Eventbrite or Amazon SNS. This hybrid approach balances simplicity and scalability. AWS service use. Here are the core AWS services used in this project. Compute. Amazon ECS run containerized service without managing service servers. API layer. Amazon API Gateway exposes external APIs securely. Service discovery. AWS Cloud Map allows service to discover each other by name instead of IP. Messaging event. Amazon SNS or Eventbrite enable asynchronous communication between services. Database. Amazon RDS, PostgreSQL or Amazon DynamoDB, persistence data storage, monitoring. Amazon CloudWatch logs and metrics. AWS S3 distribute tracing. CI/CD, GitHub Action, ECR, ECS, automated build and deployment per service, Secret Management, AWS Secret Manager securely stores database, credentials, and sensitive data. Security and IAM best practice. Security is designed from one day. Key practice. 1. IAM role per microservice. Follow the principle of least privilege. Use IAM assume role for service permissions. Security API with JWT authorization or Lambda authorizer in API gateway. Each service can only access what it truly needs. Logging and monitoring. Observability is critical in microservice. Logging. If service push logs to cloud, what logs? Tracing. AWS trace requests across services. Make debugging distributed system much easier. Scalability. Scalability is built into the design. Each service scales independently on ECS. Database can follows the database per service pattern. No shared database between services. This avoids time coupling and bottleneck. That's of CI/CD. Each service has its own CI/CD pipeline. Typical pipeline flow: GitHub, Amazon ECR, and Amazon ECS. Pipeline step. First, check out source code. 2. Configure AWS credentials. 3. Log into Amazon ECR. 4. Build and push Docker email. 5. Write the ECS tag definition. 6. Deploy to ECS and NAT. Register service instance to build to cloud map. Secrets in GitHub. Secrets are stored securely in we access setting tab. Then go to secret and variable to action and click new repository secret to append the value like this. NAT Swagger documentation. Swagger setup. Swagger is installed on each service. A root Swagger can aggregate on API. API gateway act as the unified entry point. This provides clear API documentation for developers. GitHub package share library. Why share library? To avoid duplicate code and ensure consistency. Share library include authentication utilize, event birth helpers, logins, error handling, command DTO, and so on. Distribution option, private GitHub npm register, private composer register, S3 with version. Benefit, reduce duplication, easier maintenance, consistent behavior across service. Net submodule. Each service has its own root repository. A root repository contains all services at Git submodule. Key topics: how new developers clone the project, how to update a service, how change a track golden rule when working with submodule. This structure keeps owner clear and organized. Net Microservices Architecture. Core components. User service, post service, share library, AWS Cloud Map, Amazon Eventbrite. User service responsibility, manage user and authentication, provide user profile data, emit main events, such as user created user update, integration, register in Cloud Map user share library, publish event to Eventbrite. Post service responsibility, create, update, and response, consume asynchronous events. Example, update post data when a user changes their name. Integration, discover user service via Cloud Map user share library. Fully decouple from user service. Share libraries, role, centralized reusable logic, ensure consistencies. Simplify update. This is a critical component in leisure microservice system. Communication pattern. Service discover, a Cloud Map. Services are discovered by name, not AP. Automatically update during deployment. For example, user service. User service has a subdomain, user API local, and add a post service, call user service through subdomain and post. Eventbrite architecture. Eventbrite fully decoupled service, easy to add new consumer, improve performances with a sensor processing. Example flow, user service image, user created. Event bright rolled it to post service. Post service processes the event. Architecture summary. User service manage user and emit events. Post service handle post consume events. Share library, reusable logic, climb up, service discovery, event bright, event routing. EC2. Create EC2, install Docker, ECH and ECH agent. Create AMI. Use AMI in launch template. Create auto scaling group. Enable spot instances. Attach auto scaling groups to ECH cluster. User API. API gateway, user API. Future register, login, list user, delete user, flow, client asset API gateway, point, user service, asset database. Post API, future create post, list post, delete post, flow, client asset API gateway, point post service, asset database. On-premise microservice architecture overview. For the structure, the project is organized as a multi-repo design for an on-premise deployment environment. This structure ensures clear separation of concern, easy maintenance, and consistent deployment across internal servers. GitHub package share library. A share library is published as a GitHub package and reused across all microservices, even in an on-premise setup. Each service includes an npm rc file. Service declare dependencies on username, shell lib. Username shell lib. Authentication is handled via GitHub token. This approach enables code reuse, version control, and consistent business logic across services. Swagger API documentation. Its service is full. API documentation using Swagger dependencies. Swagger API, Swagger UI Express, Swagger JS Doc. The Swagger service acts as a centralized API documentation hub, making internal API management easier for development and operation team. The event enable asynchronous communication between microservices, reducing time coupling, improve scalability, support event-driven workflow. This is especially important for on-premise system where horizontal scaling must be carefully controlled. Service discovery. Service discovery allows service to dynamically locate each other without hardcode IP address. Support service scaling. Simplify internal networking. Work efficiently in private on-premise network. Centralized login and observability. The log pipeline is fully centralized and optimized for on-premise environment. Application send log to stdown. Promtail will collect the log and send to Loki. Loki have to store in that query later. Then Grafana will query content from Loki and render layout. Data stack provide centralized log collection, fast querying and indexing, visualize visualization and monitoring. Now the time to move our application to cloud. Loads on cloud. Firstly, we create a user. Add a security credential. That's the key. Then add a permission for him. security group. We create a new VPC through the default VPC. Then create or edit on the default security group, and in this time input to necessary rule counterpart 22 and 80. Create database. In this project, we have two choices. Create to separate database, or create one for that. We create two repository, user repo and path repo. ECS needs to row, task row and task execution row. Create a cluster. Create to task definition. and create to service. We create two target group for to service. Use service target group and post target group. Load balancer. Create a load balancer for to service. Use a load balancer and load balancer for pod. Clam up. Create one namespace. Then create to service. The first, we create one event bus. If but we create the many rule, each rule will link to the target. We create one API. Each API we create to root resource. We create to VPC link. Each VPC link will link to the load balancer. The library. We do like this. Conclusion. This project demonstrates how to design a real-world microservice system using AWS best practice. Even with a simple block platform, we can apply clean service boundaries, security communication, scalable infrastructure, automated CI/CD. This architecture is production ready, extensible, and suitable for real enterprise. Bye bye.